Hi, welcome to this video showing you how you can connect the super funky 0.91 inch OLED display, the smaller of the two that are generally available. This one is the 32 line display with the super miniature Atmel processor, the ATTINY85. What a match made in heaven, those two working together, the small processor and the small display. I'll go through step by step how you get this thing working. It has been a little bit difficult because out of the box the libraries that drive both I2C on the Arduino and which is wire.h that you may have included in your Arduino sketches by Brohogan, and the OLED display drivers don't fit too well inside the ATTINY85. But fortunately, there is the tiny version of Wire, which is based on Brohogan's code, and OzOled has been adapted from Oscar Liang's code by Andreas Spice, who has a fabulous YouTube channel, by the way. If you get a chance to look at it, there's a link in the description. Here's the guy with his Swiss accent. You may have come across him before. He's adapted the OzOled library to work with the TinyWire interface. So between the two of them, they do drive the display, and they drive the 64 line display that you can see on your screen right now absolutely fine. But if you hook them up to this, they don't work. So what I've done is I've been hacking away at the code, trying to work out which bits to bash in order to get the display working. So let's get cracking. To get these two jiving together, you're going to need an Arduino Uno. You're going to need a breadboard, a 10 microfarad capacitor, because we'll be using the Uno as an ISP. Some of those. Obviously you're going to need an ATTINY85 and one of these delightful 0.91 inch 128 by 32 pixel displays. So I'm not going to go into too much detail on wiring this up and keep everybody back. Look at the earlier video on how to get the serial monitor working on the ATTINY85, and you'll see how the configuration goes from the ATTINY85 to the Arduino pins to use it as an ISP. So here's one I made earlier, all raring to go. This is missing its capacitor at the moment. I'll put that in. That has to go between reset and ground, and it is the long pin that goes into reset, the positive, and the negative goes into ground. So that's all set up, ready to be connected to the PC to download a sketch to the ATTINY85. So let's get started. I'm going to install the Arduino IDE. Okay, so there's the IDE installed, the Blink sketch on there. We're going to have to do three things. First thing is let's get the ATTINY configuration for the boards installed. These links, this is a JSON file link to the GitHub repository. These are in the description below. Once you do that, you have to go to the boards manager and install it, which I find a bit strange that it's a two-step process. If you know how to board manager, you probably want to install it at the same time. So there it is at the bottom, and we want to install. Okay, great. Now we've got the ATTINY boards installed. Next, what we want to do is we want to go to download a couple of libraries. The first of which is the TinyWire library. This is the one I said was modified to work on ATTINY processors and provide it with an I2C interface. So download that one, download the zip, into libraries. The other one is, this is the modification of the OLED library done by Oscar Liang, which is small enough but had to be modified by Andreas Spice to use the TinyWire interface. So take a copy of that, download that to libraries as well. Again, a link in the description. So those are both the libraries we require. So let's open a sketch, a new sketch. This will be our print hello world sketch. Let's just make sure that everything's going well with the COM interface here, the USB interface. I'll just plug this Arduino in. This is the Arduino Uno I'm using as an ISP. Right. Right, let's see. Let's make sure we're on the right COM port. Tools, COM13. Now I already have the ISP loaded into the Arduino. I've got the capacitor between reset and ground. Let's make sure we select the right board, and let's get the ATTiny set up for accepting code. That will involve a couple of things. Firstly, selecting the right board, and it will be the X5 range, and then the right processor, which is ATTINY85, and then we want to select the internal 8 MHz clock and make sure that sticks by burning a bootloader. So everything should be fine. ISP's loaded, we've got the MISO, MOSI, reset and clock connected to the correct pins, 5, 6, 7, and the reset on 1. We've got power to the ATTiny85. Let's burn the bootloader. Done burning bootloader. Right, now what we can do is we can include the sketches that we've just downloaded. So we're going to include a couple of libraries in this sketch. One is the where's my documents? There it is there. Arduino libraries. Let's get the ATTinyWire master opened and installed. That's done. And the other one is the OLED library. OLED master, TinyOzOLED master, and that's been installed. Right, so now let's get on cracking, get this Hello World sketch up and running, and I'll show you the difficulty here. These libraries do not work out of the box, but we'll put the code on the screen. You can see how it looks on the display. So first of all, we need to include the TinyWireM header files, which are the external references to the code in the C file, and then we're going to include TinyOzOled.h, and in setup, let's try and make this a bit more compact. In setup, we're going to initialize our OzOled control blocks, and then we're just going to print straight to the screen. So it'll then print and then loop without clearing the display. So that would be OzOled. A lot of different functions you can use, and I commend the CPP file and the header file to your reading. You can do print strings, you can print characters, you can print numbers, large numbers in this version of the library. And you can modify your own, and once you see how it works, it's pretty straightforward to modify. Maybe we'll do a little bit of that. Print string, hi there. And that's it. Should be able to run that. We've got the library installed. Let's compile it first. We've got the setup, the syntax looking alright. Let's compile that. we'll call this, I'll put a new folder here, My Sketches, and we'll call this OLED 1. That took quite a while to compile, but it's done. So now we've got the code ready to upload. The Arduino's primed with an ISP, and all the cables are installed as per the diagram on your screen. I put 4 DuPont cables on this screen here, this little OLED screen. We've got clock, data, VCC and ground. Pretty straightforward. First pin, the green pin here, is data, and we're going to connect that green pin to pin 5 on the ATTiny. So that's that pin there, and clock is pin 7. We've got VCC and ground to connect. We'll do that straight to the Uno board, and let me see, grey is ground, isn't it? Yes, grey is ground, so there is a ground over here which is going spare, and we also have a 5-volt rail here. I think the chip itself, the SSD1306, is actually a 3.3 volts, so there's a couple of voltage converters in there, a step up and a step down. I'll get onto that a bit later, hopefully. So that's the that's it connected. It's going to be awkward to see this. Let me get another camera up here. I had this one standing by in case this is going to be awkward. Get a bit of blue tack to lock it down in place. Now, which way up is this? Okay, alright, I think it's that way up. Just put a bit of blue tack, get this camera lined up on the screen. Give you a close-up on that. And we can upload this now. We've got the 2 libraries in there. We've got an init. There's a bunch of other stuff you can put in the initialization. You can set all sorts of parameters, such as the initial starting point, the X and Y coordinates. You can set the screen refresh rate. You can set whether it's inverted or not. But this is probably the bare minimum you can get away with, all the defaults being acceptable for this particular sketch. So with the bootloader burned, we can now compile and upload this sketch. Let's just make sure it's going through. Looks like it has. And oh, it's just compiled. I didn't upload it. Oh dear. Okay, it's compiled again. Now we're uploading, and I can see it uploading. Great, looking good. Do we have anything? There we go. Can you see that on the Can I zoom in a bit better? It's hard to focus on this. Let me try and set the focus a bit better. There we go. Let me try that. There we go. Hopefully you can see that on the screen now, and you can kind of make out, hi there, but it's all squished. I think it's missing rows of pixels. I think alternating rows of pixels are missing, and so what I did was I got the SSD1306 datasheet up, and I took a look at a few other libraries, and it appears there are just a couple of commands this thing needs. It needs a different multiplexer setting from the default, and it also needs a different pins setting. Obviously, you know, it's got more a bigger matrix of pins, the 64-line display. So let me show you what I did. I'm using I'm going to edit I think it's a CPP file. I'll check. I'm using Atmel Studio. You can use whatever compatible editor you want, but we're going to go into the library and edit the CPP file. So So open file, and fortunately for me, when Andreas modified the library, am I in the right one? No, I'm in the wrong one. I need to be in the OLED library. Beg your pardon. He left some, pretty big footprints around. So the instruction to set the multiplexer, and the command we use for that, or the command byte for that, is 0x DA. It's A8. Yes, it was. I'm pretty certain. And the default for that, for a 64 line display, is hex. Let me think. Hex 2F. It was hex 2F. So we want 1F. Is that right? Yes, 1F. 1F. I'll put the quotes in there for 0x. Getting my IBM assembler representation mixed up with my Arduino assembler. 1F. There we go. And 1F is, well, 1 is in the 16 position. 16 plus F, 15 is 31. Plus 0 is 32. So that's the multiplexer command saying there are 32 lines. And then the second, I'll just duplicate this. The second command is the pin setting. There are a smaller number of pins, and unless you tell it the exact number of pins, it gets a bit confused. So that's the multiplexer, and this is the pins, COM pins. And the number of COM pins, well, I think for 64 it was 12, so we just take one off, hex, and it's 02. But that's not the command for COM pins. The command for COM pins is delta alpha DA. And that's it. That's all you need to do. Let me just make sure I've got the syntax correct. Let's file and save that. And then we can go back to our sketch and we can compile and upload again. And as long as there's no bugs in my typing, we should. It's uploading now. Bingo! There you go. How about that? Full-size text. And you could do all sorts of weird and wonderful things here. Instead of just printing hi there, we can invert the text. Let's OzOled.setInverse, I think it is, setInverse display. Is it setInvert or setInverse? I think it's setInverse display. So that will invert the display. Hopefully, let's just upload that and see if it does the trick. It's uploading now, and there we go. We've got hello world, or hi there, inverted display. You've got the other commands as well. You could have a lot of fun with the scrolling commands. The brightness command is especially useful. I think I've got a copy of the code here for the brightness command. Let me just take a quick look. We could upload that one. Did I save a copy of that, or did I delete it? OLED brightness. Here we go. Yes, here we go, copy of the brightness code. Let's pop this in here. And all I do is I write brightness out and run it up to 255. It's uploading right now. Copy of that code is in the description as well if you want to take a look at it, but it just cycles through the brightness. Oops, it's upside down. I've obviously changed the orientation. Oh, that's what it is. The default orientation, I didn't set the default orientation. I did on this one. So I don't know if you can see that. Let me, wait for the right hash of this. But there you go. It's on the screen right now. So it goes from brightness 011 up all the way up to 256, and then back 255, and then back down again. and you can see the brightness on the screen. So there you go. Those are the brightness levels. I must admit, the very low level of brightness isn't particularly low, but anything to help save power on these things, the ATTINY85 and on the OLED screen, are to be welcomed. Anyway, I hope you enjoyed that. Links in the description, code in the description. If you did, give me a thumbs up. All the best. Cheers.